that this is a PNP. This terminal here is the base. Center pin is the base. This pin here is the emitter. And then this pin here must be the collector based on the results, based on those results. Now, sometimes you have a bit of a different looking transistor. You will have one that looks similar to that. It actually looks like this one here. This one here. This is the one that you're going to be looking at. And then the other type you have is this one. So it kind of looks like a can. Notice that there is a tab on this can here. That tab points to the emitter. So not points to, that tab, the closest pin to that tab is the emitter. So then you just have to figure out which one is the base and which one is the collector. And when we go into the lab, I'll show you how to look at that, and we'll also do a couple practice ones here. So so this is how you're going to ring out the PNP. So you got an NPN and you got a PNP. So taking a look on your meter, you got a situation like this. So you're reading 0.61 volts there. So you can see 0.61 volts. And you're reading between the base to the collector, 0.6 volts. You can see over here, I'm leaving this on there. The white is still on there, right? My white lead, this is my black lead, right? So that's my negative. It's still on the base, and I'm reading 0.7. I'm leaving that on the base, and I bring my red over to this one here, and we don't know what it is, but it's reading 0.7. So then we say, okay, yeah, all right, we can identify. That's the emitter, that's the base. The other one, by process of elimination, is the collector. Looking at this one here, the base, I have my black lead or my negative on. If I was getting OL, in other words, if I was seeing something like this where I notice I have my positive now on the base, and it doesn't matter if I go collector or emitter, I'm going to see OL. If I have that, my positive on the base, and I'm not getting anything, it means that, well, it's not an NPN, it must be a PNP type, because if I've got my red, my positive on this pin, and it's a P-type material, I'm going to get a value. If it's not a P-type material, I'm not going to get any value. I'm going to get OL, in which case this, as we're seeing, is a PNP type material. Let's take a look at this one here. So what would this be? I've got my red on this here, and I'm getting a value. I'm getting a value, right? So automatically, you know it's a P-type material because my red is a positive. I'm on the center pin as my base. I'm going to get a P-type material. I'm in a P-type material because I'm getting a value. And I check to my pin over here. I'm getting 0.7 volts. I compare it to this one. I haven't changed the red. I'm still on that center base. That's a positive on it, so it must be an NPN. And the collector, sorry, we don't know that it's a collector, but I'm seeing 0.6. The higher junction is the base to emitter. So we can call that the emitter. We can call this collector. If I have this on here and I'm not getting any reading at all, it must be a PNP type. Okay. Let's talk about the junctions momentarily. So inside there are, so this is a bipolar junction transistor. And what that means, bipolar junction, is that there are two junctions. There is a base to collector junction right there, where you can see over here, the right over here. So base to collector junction right there. And there is a emitter to base junction. So a base to emitter and a base to collector junction, a base to collector junction and a base to emitter junction. So that's why it's called a bipolar junction transistor, because there are two junctions in there. So you will see it sometimes written as a, and I've written it here, a collector base junction or a CB junction or an EB junction. You will see that. So what that's referring to is the emitter to base junction or the collector to base junction. Okay, so when you see that, That's what that's referring to. Let's watch this